Today let us solve LeetCode 532 K-diff pairs in an array. We are given an array of integers called nums and an integer k. Our task is to find the number of unique pairs whose absolute difference is exactly equal to k. For example, suppose the array is 3, 1, 4, 1, 5 and k is 2. This is our array and this is our k. The valid pairs are 1 and 3 and 3 and 5. So the answer is 2. Now notice that the number 1 appears twice in the array, but the pair 1 and 3 should be counted only once because the problem asks us to count unique pairs. The first approach that will come to mind is to check every possible pair using two loops. That approach would work, but it would take quadratic time. So let's write that down. Check every possible pair. Time will be O of n squared. So this approach is not optimal because our constraint is very huge. These are our constraints that num dot length lies between 10 power 4 and 1. So we need to think of an optimal approach. Instead, we can solve this problem using a frequency map. A frequency map stores every unique number in the array along with the number of time it appears. Now there are two important cases. The first case is when k is greater than 0. We know that absolute difference between two numbers must be equal to k. Instead of checking both directions, we can simply take every unique number and check whether that number plus k exists in the frequency map or not. For example, if the current number is 1 and k is 2, we check whether 3 exists. If it exists, then 1 and 3 forms a valid pair. Similarly, if the current number is 3, we check whether 5 exists. If it exists, then 3 and 5 forms another valid pair. We only check number plus k. We do not check number minus k because that would count the same pair twice. Now let us discuss the second case when k is equal to 0. If k is 0, then the difference between the two numbers must be 0. This means both numbers must be equal. For example, the pair 1 and 1 is valid only when the number 1 appears at least twice in the array. So when k is 0, we count how many numbers have a frequency of at least 2. So let us dry run the first example. So let us quickly write down the pseudocode. We need to create a frequency of map of nums, then initialize answer equal to 0. If k equals 0, then for every number in the frequency map, if its frequency is at least 2, then increment answer. Else, for every number in the frequency map, if number plus k exists, increment answer. And finally, we return answer. Let us dry run this algorithm. For nums equals 3, 1, 4, 1, 5 and k equals 2. The frequency map becomes this. 3 will have 1, 1 will have 2, 4 will have 1 and 5 will have 1 frequency. Because k is greater than 0, we check num plus k. For 3, we check 3 plus 2 equals 5. 5 exists, so we count the pair 3, 5. For 1, we check 1 plus 2 equals 3. 3 exists, so we count the pair 1, 3. And for 4, we check 4 plus 2 equals 6. 6 does not exist. And for 5, we check 5 plus 2 equal to 7. And 7 does not exist. Therefore, the final answer is 2. Now dry run for k equal to 0. So this time our nums remain 1, 3, 1, 5, 4 and k equals 0. The frequency map becomes this. And because k is 0, we count numbers appearing at least twice. Only 1 appears twice. Therefore, the unique pair is 1, 1. And the answer is 1. Let us also quickly write the Python code. We have written the pseudocode but not the Python code. So because absolute difference cannot be negative, we just make if k less than 0, then we return 0. Then we initialize frequency equals counter nums and pairs equals 0. So this is a short way to get the frequency map just by writing counter nums. This is something important that you can remember. Write it somewhere, store it somewhere. We can use counter to get nums. Let's check how does counter looks like. So in Python, counter is a specialized dictionary subclass from built-in collections designed specifically for counting the frequencies of elements in an iterable. So this creates something like this. Whatever array is given into them, it converts them into frequency map. Now if k equals 0, then we need to do this. So for count in frequency dot values, if count is greater than equal to 0, pair plus equals 1. Else we check whether num plus k exists. So for num in frequency, we check if num plus k in frequency, then pairs plus equals 1. And finally we return pairs. We already have tried to do dry run. I hope you understand the code very easily. Let's test it. Let's now submit it. Tests have passed. Okay, so all the test cases have passed. So question can be, why we do not count duplicates? We iterate over the keys of the frequency map, not over the original array. Each unique number is therefore processed only once. For positive k, we always search for num plus k instead of checking both num plus k and num minus k. This means the pair 1, 3 is counted when processing 1, but it is not counted again when processing 3. Creating the frequency map takes O(n) time, so complexity analysis. Creating the frequency map takes O(n) time. Iterating over the unique numbers also takes at most O(n) time. Therefore, the overall time complexity is O of n. The frequency map can contain up to n distinct numbers. So space complexity is O of n. So our time and space complexity is O(n). That is because we are using frequency map. To create it, it requires only O(n) time. And when we are checking if num plus k in frequency, that is also taking O(1) time. That is taking O(1) time. So that optimization is made by some randomization by Python. If we were to create on our own, then it would take log n time. So it would be n log n if we try to create frequency map on our own. Now let's discuss common mistakes. First is checking every pair. A brute force solution using two nested loops and takes O(n) square time. This becomes inefficient for large arrays. Second mistake is ignoring uniqueness. Iterating directly over the original array may count the same value pair multiple times. Then treating k equal to 0 like other values. For k equal to 0, checking whether num plus k exists is not enough. The number must appear at least twice. Checking both directions. Checking both num plus k and num minus k can count the same pair twice. Only check num plus k. So the main idea is simple: create a frequency map. When k is positive, count every unique number for which num plus k exists. When k is 0, count every number appearing at least twice. This gives us an efficient solution with O(n) time and O(n) extra space.